In 2.6, we're going to be, the topic is called formalizing relations and functions. And it's going to cover some concepts that you probably have heard before. I know I've talked about it in Unit 0. I know I talked about it a little bit in Unit 1. And so your basics that you're going to have to know in 2.6. How can I identify the domain and range of functions and non-functions? So first off, if you don't remember what domain is, let's write down what domain is. I'll scoot this up for you. The domain are your x values. They're also known as your inputs. They're also known as your independent variable. Domain are your x values, your inputs, independent variable. Whereas range is your y values. They are your outputs. They are your dependent variables. The next thing, because you have heard these before, you're going to be asked to describe your domain and ranges of certain numbers. But you're also going to be asked, is it a function? It is a function. Let's talk about function. And I'm going to underline the word function real quick. It is a function when, or it is a function if each x has its own y value. It is a function if each x has its own y value. In other words, no x values repeat. It is a function if each x has its own y value, which means no x values repeat themselves. They're not cheating on anything. Each one has their own deal. It also passes the vertical line test, which is something we wrote down before, but I'm having you write it down again because that's what this worksheet, this next section is going to ask you to do. So let me give you an example that looks like number 2 on the next worksheet I'm going to give you. And number 2 has a bunch of ordered pairs. The first thing is a squiggly. That's a solution set bracket. It's a set of numbers, 5, 2.2, and 3, 2.6, and 1, 2.6, and 0, 2.5. There's 4 ordered pairs inside this set of numbers. When numbers are written in this way, if you see the curly brackets, this means a set of numbers. And so I know this is really small, I wrote it, but it says set, S-E-T. Curly brackets means it's a set of numbers. This is the set of numbers. When you see the parentheses in this case, it means it's an ordered pair. It's a location. It is something you can graph. You can plot these as points. So I'm going to be asking you, when you give me your answers, to give me your answers in terms of a set, not in terms of ordered pairs. Ordered pairs means I can graph them, whereas a set of numbers are in the solution set, meaning it's just a bunch of numbers. So here we go. Here's your questions. What's the domain? Question mark. What's the range? Question mark. Is it a function? Is it a function? Those are the 3 types of questions we're going to be asked for the first 4 questions on your worksheet. What's the domain? What's the range? Is it a function? So I'm going to do this the way I want you to answer it. I want you to answer it with a capital D with a colon. The D is going to represent domain. The domain is made up of, and I want you to use a solution set bracket. A set, a curly braces. Curly bracket is what they're called. Braces is what they're also called. Do you know what your domain is? And your domain is, I always want you to start off with the smallest number. List smallest to largest, because that's how it is on the SATs. And I do want you all to go off to college someday. And on those types of tests, they are always listed from smallest to largest. On the SBAC test, they should be listed from smallest to largest. So I want you to get used to going and writing things down smallest to largest. It doesn't change the domain. It's just what you're given. What is the domain? What's the smallest domain that we have?
0.
What I'm asking is, what's the smallest x value that we have? That's 0. That is the smallest x value we have. What's the next smallest?
1.
And the next smallest?
3.
And the largest?
5.
And then I'm done with listing my solution set, so I close my set with the braces at the end as well. Here's my domain. And the domain means, what are your x values? I have 0, 1, 3, and 5. We give it in order from smallest to largest. Second question, what's the range? Capital R. Put a little colon. Solution set. What is your smallest range? I'm not asking what the smallest one was for your domain. I want to know what the smallest range was. What is the smallest one?
2.2.
Then it goes to?
2.5.
Then it goes to?
2.6.
And every time I separate them by, is there another one?
Yep.
Do I have to write down both 2.6s? No. These solution sets, and I'm going to write that down right here. You do not list them twice. Do not list them twice. Little star, little point right there. Do not list them twice. I did not have to list the 2.6 twice because the set means 2.2 is in the range, 2.5 is in the range, 2.6 is in the range. I don't have to say that there's 2 of them. All I have to say is that 2.6 is in the range, and I have covered both of them. It's in my set of numbers. I've answered the domain. Done. I've answered the range. Done. My last question, is it a function? I want you to take a vote. Let's do it as a vote. How many of you think that this is a function? Raise your hand. How many think this is not a function? Raise your hand. If your hand was up, you were correct back in the day. This is, yes, it's a function. Who can tell me why? Rachel.
Because none of the x values are 3.
because none of the x values repeat. That's why. Perfect. Pretty easy question. Now let's go jump to something that looks like number 7. The first 4 questions you have will be like number 2. Number 7 says f of x equals negative 4x plus 3, and then it has a set of numbers, negative 1, 0, 1, 2, 3. And it will say, find the range for the domain given. Find the range for the domain given. And it has f of x equals negative 4x plus 3. And it has negative 1, 0, 1, 2, and 3.
Is that the x or is that the y?
The domain given. So what is this? This is your x, because it's the domain is given. Our x's are given. And so we need to find out what the y values are. What I want you to do is I want you to make a table. Make a table when you have something like this. I want you to have an x and a y, and I want you to plug in these values and figure out what the y values are. When x is negative 1, when x is 0, when x is 1, when x is 2, and when x is 3. Now there's a variety of ways you can do this. You can do it by hand, or you can do it with a calculator. I want to show you the first method by hand. When x is negative 1, you would plug negative 4, and instead of x, you would have to plug in negative 1, and then plus 3, and then you would have to work that out to figure out what the y is. If you know what that is, work it out in your head real quick and say it out loud. What is it? Oh, big difference. Okay. The answer is, say it again.
7.
Oh, we're on the same page second time. 7. Good. And we could do that for each of the numbers. I want to remind those of you who are calculator literate, meaning you know how to use the calculator and you want to save yourself time. Don't forget, there's a table function on our calculators that I suggested for you to use back there. All you have to do to get to it is press the mode button, and you can go from computation mode to table mode, which is number 7, and you can punch in your function, negative 4 alpha x plus 3, and so you can type in your function. On the newer calculators, it'll ask you, do you want a g of x? You just press enter. You can go right by it. Where do we want our table to start? What's the first value we want it to start at? So I want it to start at negative 1. I have to type in negative 1 to start. Where do I want it to end?
3.
What is it going up by?
1.
And when you do, what it's going to do is take the negative 1, plug it into the function, and it's going to pop out a number just like it did there. And so if I want to, I can do it by hand, or if I'm calculator literate, meaning I know how to read and use my calculator, I could, in theory, use the calculator to do the whole table for me. The faster you are on the calculator, it goes a little quicker sometimes. Find the range for the domain given. Do I know what the range is? Which one's the range?
Y.
So now I just go like this, and I could put down that my range is smallest to largest, negative 9, negative 5. But it's not in order. It is in order because it's smallest to largest. 3, 7. Here's my range. It's my range of numbers right there. Last example. Number 13. If f of x is equal to x squared minus 15 and f of a equals 49, what is the value of a? Question mark. If f of x is equal to x squared minus 15 and f of a is equal to 49, what is the value of a? This question will confuse a lot of you, which is why I wanted to do it with you. If f of x is this function and f of a is 49, what is the value of a? Here's what it's saying. If your input is a, I'm going to put input, and your output is 49, what does a have to be? Output. So if my function's output is 49, when my input is a, this is what they're asking you to figure out. They're asking you if the output is 49 and your input is a into that function, what does a have to be? Here's what you're going to do. You're going to get the a by itself. You're going to do the opposite of subtracting by 15. And Gracie, what is the opposite of subtracting by 15?
Adding 15.
Do I just add 15 to this side, Gracie?
No, you added the 49.
Which is what? Do you know? I know that's hard to do in my head. That's why I was hoping you could do it. She has a calculator. 64 equals a squared. And something times itself equals 64. The opposite of a squared term, the opposite of something to the second power is square rooting. In case you didn't know that. The opposite of a square, opposite of x squared is to square root x squared. I'm going to put that off to the side because that's something that I'm hoping we know. If you don't know, there is a square root of button on our calculator, but we have to go from the table to computation mode. Square root. And I hope you know something times itself is equal to 64. Do you know what it is?
8.
Well, guess what? You're half right. 8. 8 times 8 is 64, but there's another possibility. Something times itself equals 64. What else? We don't know. Ooh. Okay, this is for you advanced students in the class. Something times itself equals 64. 8 times 8 is 64. Something else times itself equals 64. And it's very similar to 8.
7.99.
No. Okay, I'm just going to tell you. What's a negative times a negative? So, is there a second possibility?
Negative 8 times negative 8.
There's a second possibility as well. Negative 8 times negative 8 is a positive 64. What that means is we can say A is equal to a positive or a negative 8. I'm glad I talked about that because that tells me that they're not teaching that to you in 7th and 8th grade. So I want to highlight that as something that you're going to need to know from now through calculus. For you freshmen, some of you will be taking calculus your senior year. Some of you won't. Got it? Okie dokie. We're going to stop notes right there.